All right, so today we're going to go over naming molecular compounds, which in my opinion is literally the easiest part of this entire unit. Um, we're going to be able to write the chemical names and formulas of molecules, so things that are covalently bonded together, not ionically bonded, not the transfer of electrons, not a metal bonded with a nonmetal or a positive and a negative. These are all negatively charged. These are all nonmetals. So everything on that right side of that stair step on the periodic table, that's what we're dealing with only on molecular compounds, with the exception of hydrogen. Um, that is on the left side. I don't want you to say, but what about this? So literally all you need to know there's a couple of other rules, but the main thing you need to know about naming covalent compounds are these prefixes. So mono is 1, di is 2, tri is 3, tetra 4, penta, hexa. If you speak Greek, this will help a little bit. It's not all the same, but it might help you if you're trying to remember it on a test and you didn't study very well. But this is just 1, 2, 3. You will have to memorize these. I'm sorry. I don't know. That's just something I can't get around. You've got to memorize that. It'll come in handy later in your life. You'll see mono a lot. You'll see di and tri and tetra, penta. So this, I mean, it's not something that's useless. So do memorize those before the test, but really the rules for naming, you're going to use those prefixes that we just saw, these, and we're going to put them in front of the names of the atoms. So, and then the second word in our naming or our molecule will be ending in "ide." So, for example, you have N2O4. So this is di and this is tetra. So this would be dinitrogen, tetra, oxygen, but we changed the ending of oxygen to "ide." So dinitrogen tetraoxide. So that's pretty easy. And then you have one here. You would think it would say monocarbon, monooxygen, or so, and that would be changed to oxide. So monocarbon monoxide, okay? But the first atom in any molecule, if there's only one, you don't have to say mono on the first one. So I use this example because it's kind of common. We hear carbon monoxide all of the time, and it follows that rule. So it changed the ending to "ide," and carbon it's not monocarbon, okay? You don't say mono on the first atom of the molecule. So this one would just be carbon monoxide. Next one, it wouldn't be monosilicon, okay? It would be silicon, just silicon. There's 2 of them, so dioxide. So silicon dioxide. Okay, so if there's only one of that first element, make sure you don't write mono for it. And writing the formula, so if they give you the word and you need to write the formula, so trisulfur hexafluoride. So basically sulfur's symbol is S, and there's 3 of them, tri, okay? So it would be S3, and then hexafluoride. So fluoride it would be an F, and then hexa would be 6, so it would be S3F6. Another example, carbon pentaoxide, okay? Carbon pentaoxide it would be 1 carbon. Penta is 5, so you do need to memorize these. But that does sound very close to the 5 in Greek, so that might help you if you speak Greek. Carbon pentaoxide, there would just be oxygen, 5 of them, and 1 carbon, so 1 carbon, 5 oxygens. And tetraphosphorus dioxide. So tetra is 4, kind of sounds like you're 4 in Greek, but not exactly, but still. And you make sure you spell these right, because if you don't spell it right, I do count off, simply because you can kind of just, I don't know, I want you to spell it right. They're only like 4 or 5 letters each word. Some of them only 3 or 2. So anyways, tetraphosphorus, there's 4 phosphorus and there's dioxide, so 2 oxygens. So 4 phosphorus and 2 oxygens. And I'm glad this is here because I almost forgot to tell you. don't reduce the subscripts. So for example, with ionic bonding, this would be a no-no, right? We would have to reduce it to SF2. But here on molecular compounds, they are bonded this way. That you do not reduce these subscripts. In every molecule, you will for sure find 3 sulfurs and 6 fluorines in trisulfur hexafluoride. In ionic bonding's case, it's a crystal. It's a different bonding. It's just different. They're in little squares built up on each other in repeating patterns, so they do break apart. So we do usually talk about ionic compounds in the sense of the most reduced form of it. But in molecules or covalently bonded molecules, or something else you will hear, molecular compounds, all the same, you do not reduce those subscripts. That's it. This is like the easiest part of the unit. So all you need to know are these beginnings and some of the etiquette of writing it. So monooxide, one thing that's not written here is that you don't write 2 O's right here. It's not monoxide, it's monoxide, so you do get rid of one of those oxygens. But other than that, this is easy. You just need to know these right here. This is more of a memorization lesson, but it's pretty easy for anybody. I mean, I don't speak Greek, and these were something that I had known for a while. You learn it in other classes, and you learn it in life, so